Hey, welcome back to the Acosta E.T.F channel, where we talk all things engineering, technology, and finance. In this week's episode, I'm going to show you an old video of some engineering work that I did back in college. Why am I going to do this? Well, the hopes is to encourage and inspire you to be an engineer. There's a lot of great things that we do as engineers daily, and we take technology and see how it fits into the world to make the world a better place. But before we jump into the video, there's three things that I need you to do for me. First, I need you to like the video so this content can be pushed to as many people as possible to inspire them to become engineers. Second, subscribe to the channel. And third, turn on your notifications so you don't miss any new content when it's ready from our channel. So this was a project that I worked on when I was in my second master's at Villanova. So the purpose of this project was to look at a particular application from a cybersecurity perspective. What you're going to see is I simulated a car, so a car where you drive every day to and from work or wherever it is that you're going. The car's computer generated information. That information would be encrypted, send over a network to a private server that sits somewhere in the world. That private server would decrypt the information and present that information over to the insurance companies. And the insurance companies would then base your rates off of your driving habits. I know we have technology that already handles this. This class made you look at the problem from a cybersecurity perspective. So I saw different ways in which we can improve the process that we currently have. And then I took the code to simulate that to create a working prototype. Let's jump into this short video on the really interesting work that I did during my time at Villanova.
Let's take a look at my design project, set up the stage, right? So let's look at the auto industry, right? And so auto insurance. So in 2016, right? So here are the numbers, 222 million licensed drivers, about 268.8 million registered vehicles. And if you look at the insurance company as a whole, should I say the car industry, the insurance side of it, it's about 18 billion. Total GDP, right? So a lot of money, a lot of people, and a lot of cars involved, right? So when we look at it, how do you accurately evaluate drivers based on their driving habits, right? So if we kind of look at that, I know you're thinking, right, there's something out there already that they have to accurately take a look at, you know, how well we drive, and it's the progressive snapshot. Companies have a lot of different things, but really they're all the same, right? So they take a look at, you know, how well you drive based on the data that's produced from this. Problem is though, right? So there's no authentication to the cellular network. And this is all from a research finding that was done. I actually put it in the hyperlink, so if folks are interested, you can actually take a look at the article. Again, so there's no traffic encryption, firmware is not signed or validated, there's no secure boot. Talk about a huge fail in security, right? So it's susceptible to man-in-the-middle attacks, fraud, and say, for example, even if they do end up fixing these problems, which I haven't found any research until this day if they have, how do we know that our data is secure with these companies, right? Can we really trust them? If we all remember what happened with Wells Fargo back in 2016, they opened up 3 million fraudulent accounts with our data, right? So how can we trust these companies? So here's the solution that I'm proposing. So first solution, each vehicle will produce its own data on its ECU, so the electronic control unit. The data will be encrypted before sending it out over the network. Private server will receive the data, verify the message, decrypt the data. Then after it does that, the server will create data chained hashes, an idea that I got from blockchaining. And then that secure data will be presented to the insurance companies for driver evaluation. So real quick, this is kind of how it looks like if we want to take a look from a graphical perspective, right? So data is being generated at the vehicle. So for example, if you look at, say, engine duration, how long the car was on for, how many miles you traveled, what was your average speed, right? So all that will be generated in the car. You're going to have encryption that goes on to make sure that once you send it over the wire, no one will be able to sniff it, see it, or if they do find it, it's just garbled up messages that they can't make any sense of. It goes over the internet and then it goes to the server. The server's job is going to decrypt that data and then also generate hashes. One thing that I did forget to mention, the encryption and decryption happens with the private key. So I do want to put that one in there. And then again, then once the data is decrypted and you have the hashes, then we send it over to Flo over there at Progressive so she can give us our rates. So real quick, how is this happening? So in order to simulate this whole process, I wrote software. It's going to take 3 major key aspects. So socket programming, which is the communication, right? So you're going to see communicating from the vehicle to the private server. Encryption, as I mentioned, it's using a private key in order to do that. And then blockchain like hashing. So I got ideas from the blockchain where I can take the data and then I can use a hash to create another hash, and so on and so forth, and making sure that the data doesn't get changed at whatever point. And so just to take a real quick look at how the communication happens. So this is a simple diagram. To your left, you have the server. To the right of that, you have your client, which is the car. So server is the first one to come up, right? So you have your socket. Once it has a socket, it binds to it. Then it's ready to receive the messages. And that's then when the car comes up. The car creates a socket. Then it sends a message to the server. Server then replies. Then the car receives it. And then it decides whether it needs to close that connection or keep going. But it keeps going into a loop. And that's really how the communication happens. And then how is the messages sent over the network? So this is something that a custom message that I created, right? So it's going to be sent over by VIN, engine duration, miles traveled, average speed, and a sum check. So the sum check is really there just to make sure that once the server receives the messages, it can check to see if the data is not valid at whatever point, and if it isn't, it'll ask to send the data over again. So with 5 minutes left, let's take a look at the demo. Demo's a really cool part. I have 3 terminals that are opened right now. In the interest of time, since I only have 5 minutes left, I ran the software ahead of time. And so to the left, you see here the vehicle. So we have vehicle on this side. On the right side, we have the private server. And on this side, or on this terminal, you're going to see the data verification that we send off to the insurance company. So if you can kind of take a look real quick, right? So you have 3 vehicles. VIN number, engine duration, miles, average speed, and you can see, right, they're all different. 86, 87, 88 is what it ends up with. So we can see here that all information was generated for each 3 vehicles. And then, as I was explaining before, right, it's going to encrypt the data. So if you take a look at, say, for example, the first one, right, so VIN number ending in 86, engine duration is 14 hours, miles traveled is 494 miles, so it equals to about 35 miles an hour. So if you take a look, right, so here's what the encryption looks like for the VIN, the engine, and the miles traveled, and then your average speed, right? So obviously we can't make sense of that once it gets sent over the wire. So if we kind of take a look, it goes ahead and encrypts all the information for all the data. And then now this is the interesting part, right? So it gets into sending the message. So the first thing that the car does is it checks to see if the server is alive. So it does that by sending a SYN message. And as you can see over here, it says received message SYN. Once it receives that, then the server responds by acknowledging that. And that's what we see here with the ACK message. And then now that lets the car know, hey, I know that you're alive, so let me go ahead and send the data. So what you see happening next is that the messages actually get built and they get sent over the wire. So if you take a look, this is kind of what it says by final message being built. And then it sends the packet over to this IP address, which is obviously internal to my computer on this particular port, which is exactly what this server is listening on. So you can see here that it receives all that. And then also one of the things that it does is, if you remember what I said previously, it has a checksum. So it goes through and it takes a look at that checksum to see if the message is good. And if it is, it sends this message back saying sent okay. And this is actually what the car receives, is, you know, the message that is okay. If it isn't, there's code in here that actually sends the message again. And I believe off the top of my head, the timeout that I put in there was for 10 tries. And then after 10 tries, if it doesn't do that, it just saves the data locally and it tries again at another point. So if we go and we go down, so I'll go ahead and show you, right? It sends all the messages. And then finally gets to the end where it sends the last message and it says, okay, I'm getting ready to terminate my connection. So once we go ahead and we scroll down here to the server side and it goes, okay, I want to terminate my connection. The car sends over the fin message. So that's basically stands for finish. The server replies back and says, okay, fin plus ACK, meaning, hey, I got your message before, go ahead and terminate. So that's pretty much the end of the vehicle side. The vehicle has no part in that. So if we kind of take a look at what goes on next over here, it has all the data here, right? And so one of the interesting ideas that I got off, you know, coming up with this solution, I said, well, how do I make sure that now that I have the message here on the server side and it's decrypted, right? How do I make sure when I present this to the companies that they don't do anything malicious with that data, right? So then I looked into blockchaining and I figured out that you can actually create a hash that's associated with the data, and then you chain them all together to create new hashes. So if we actually take a look, the first bit of data over here, right? So here's the VIN, engine, miles traveled, and the average speed, right? So this one is special. This one is called the Genesis. And so the Genesis is the first one. So obviously previous hash would be 0. There is no one. And it generates the new hash, which is 622 over here. So then if you look at the second one uses the previous hash and creates a new one. and so on and so forth. So it keeps doing that until you get all the way to the bottom. And then once you get to the bottom, it's pretty much done, and you could present the data to the insurance companies. So if we take a look, we have the hash text file and then the output. So what I can do now is I can run the application and say, let me verify that data. So hash output. Oh, and I forgot, I even put checks in the code to make sure that you actually put the right files in the right order. So you can't even, I guess, fake out the program, I guess, in that point. So if I put the right one, I can say, okay, great. Data is secured, as you can see here. So the last thing that I want to do is, let's say if I have a good friend of mine that works in the company, I said, hey, you know what? I kind of been speeding for a little bit. Can you hook me up? Can you make sure that I don't get charged differently? So if we look over here, I'll go with this last one over here. He's obviously, this is not realistic. It was generating random data, but apparently he's traveling 146 miles an hour. So I call up my buddy and I say, hey, can you change that? He's going to go ahead and change it to somebody else in 7.6. So that's no longer my VIN. It's somebody else's VIN. They can charge somebody else. We can just go back in here, run the program again, and say, and you can tell here, oh, you know, the data was compromised. It gives you the VIN number and it tells you exactly what the hash that was calculated and what it was expected. So then if we go ahead and change that back to 88 again, which is the original VIN, you can clearly see that we can run the program again and the data is secured, and we know that nobody messed around with that data. And then once you know that the data is good, right, they can do their further analysis. Like I have over here, I pulled up the output text file, and then I did the averages. So you can tell that driver 1 is on average 25.7, driver 2 is 25.6, and driver 3, I guess, is the speed demon. So we're going to give him the higher rates compared to, you know, drivers 1 and 2.
So there you have it. A really cool project that I worked on a couple years ago, where I took a look at a problem and we looked at it from a cybersecurity perspective. How do we improve the process using our engineering skills in order to make the world a better place? In this case, be able to effectively assess what someone's insurance rates should be based off of their driving habits. I hope you're able to see how we're able to take technology, apply to a problem, and change the world for a better place. I also hope that this video is able to inspire you to look into engineering as a possible career. Now remember, don't forget to like the video so it can be pushed out to as many folks as possible to inspire them to become engineers. Also as well, don't forget to subscribe and turn on the notifications so that way you get all the latest content from our channel. We'll see you on the next video.